Welcome to our series on IBHL final test preparation. Well, most test papers begin with polynomials, and here is the very first question from this test paper. Those of you who want to really practice, they can actually ask for the PDF. Send an email on globalmathinstitute@gmail.com. Now, this question is to find the equation of quadratic polynomial, means degree 4, which you can see from here, ax to the power 4 plus bx cubed plus cx square plus dx plus e from the given data points. So x and y values are given to us from -3 to 4 integer points are given to you. Now we need to find the values of a, b, c, d, and e. Definitely we need 5 equations to work out. Here is my approach. I'm going to actually begin with the finite difference just to show you that this is indeed a degree 4 polynomial. That means fourth finite difference should be constant. Thereafter, you will also learn a very important formula which is not being used much, but it's my favorite. I've been using it for a long time. For how from the finite difference we directly get the value of leading coefficient a. So that knocks off one of the coefficients. As you can see, value of 0 is given to us. That means we know the value of e also, right? So we have already knocked off two of those important 5 coefficients to be figured out. So now let's see the beautiful approach of finding the solution of this problem in the shortest time and in the best possible way. I am Anil Kumar. Welcome to your YouTube channel. This is where your questions and our solutions meet, a learning platform absolutely free for the last 15 years. Now, let's take up the solution of this. As I said, we'll begin with the finite difference. Now, finite difference is kind of y2 minus y1, right? So, we'll do that now. So basically, we are finding difference between these two consecutive terms. So 46 minus 226. Some of you can use calculator, right? So that gives you 180 negative sign, of course. And now do 0 minus 46 minus 46. Minus 2 minus 0 gives you minus 2. Minus 2, take away minus 2 will be 0. 6 minus of minus 2 is 8. 70 take away 6, 76 take away 6 is 70. And from 310, when you take away 76, you get, so 10 take away 6 is 4, and you get 234. So that is the first finite difference, and indeed this is not constant as expected. So we'll go in for the second, right? So minus 46 minus of minus 180, that means 180 minus 46, that gives you 134. Now minus 2 minus of 46 will give me positive 48. 0 minus minus 2 will give me positive 2, positive 8, right? And this is 62. And that is, so 4, and then we get 164. Correct, 16. Correct. So that's what you get in this particular case. And now let's look into the next finite difference. Okay, so 48 minus 134. So we made a mistake here. So when you say minus 2 of minus this, so it'd be actually 44, not 48. Let me correct that. Good, we figured it out. Okay, better. Correct. So 44 minus 34 gives us minus 90. 2 minus 42. 8 minus 2, 6. So if you take away 10, it is 52, but it's 54 because we're taking away this, and now 2, 102. Perfect. So third finite difference is also not constant as expected. Now what happens? Now if you do this fourth finite difference, what you get is 48 in all of them. Correct? Now since fourth finite difference is constant, so we normally write like this: delta fourth finite distance, I like subscript, which is constant, is 48. Correct. Now it confirms that your polynomial is indeed a quartic polynomial. Correct. Now here is a very important relation which gives you directly the value of a from the finite difference. Now a is equal to the finite difference, whatever it is, constant over n factorial. So that is the most important formula which you should definitely know. Okay, so from here we know the fourth finite difference, which is 48, and 4 factorial, right? 4 factorial is 24, so that gives us a value of 2. Now 4 factorial means what? Let me write down here. 4 factorial means 4 times 3 times 2 times 1, correct? It is multiplication 1 to the number. That's a notation, and that 4 times 3, 12 times 2, 24. Makes sense. So we have found that the value of a is 2, and therefore now at least we know that the function f of x is equal to 2 times x to the power of 4 plus b x cube plus cx square plus dx plus e. So we have put 2 for a. Correct? We could also change the value of e. We'll do it on a fresh page. Let's move on. So at least we have now the value of 2. Okay. So since we know a equals to 2, so we have this function f of x is equal to 2 times x to the power of 4 plus b x cube plus cx square plus dx plus e. Now we can place the value 0. So at 0 the function is minus 2, right? Since there's limited space, I'll just write here f of 0 equals to minus 2, right? So when you put 0, all these terms will be 0, so you get the value of e. And so we get the value of e as equal to minus 2. Correct? So now the function f of x can be written as 2x to the power of 4 plus bx cube plus c x square plus dx minus 2. Makes sense, correct? Since e is minus 2. So we got two values. Now to get the other three values, it's good to check on the other values. One of them should be minus 1, and the other one we can take as plus 1. So BCD can be figured out, correct? I wrote dx. Okay, makes sense. You have to be careful while working with this, since there are many equations involved. Keep checking what is going on here, okay? Right, so f of minus 1, which you know is 0, right? So we'll write this 0 later. But if I put minus 1 here, I get 2 times minus 1, sorry, to the power of 4 plus b minus 1 cube plus c minus 1 square plus d minus 1 minus 2. And that should be equal to 0, correct? So when you put minus 1, a positive even power, it becomes positive number. So this can be written as 2. That'll be negative b, right? And this will be positive c. Here will be negative d minus 2 equals to 0. You get the whole idea. So we got an equation here saying that uh, now 2 minus 2 is 0. So that means minus b plus c minus d is equal to 0, right? So we get this equation where we are writing from here that these three things are 0, right? So let me rewrite this equation here. So we have minus b plus c minus d equals to 0. Because as you can see, minus 2 plus 2 is 0, right? So all the three things when combined like this is 0. Correct. Okay. So we have another important relation here. Now let's put f equals to plus 1. So if you put plus 1 for the function, the result is going to be minus 2, right? And in the function, I'm not plugging it 1 in every case as I did with minus 1. I'll just put in the equation directly. So you get 2 plus b, right? Replacing x with 1, right? Plus d. And e is minus 2 for us, right? So minus 2. And this should be equal to minus 2, correct? Correct. So we get b plus c plus d equals to what? B plus c plus d is minus 2, right? So that gives you b plus c plus d equals to minus 2. Makes sense, right? So, so there we go. B plus c plus d is minus 2. So we have one equation here, which is minus b plus c minus d. Let's give them some numbers, right? So, okay, we didn't start with giving numbers. So let me just say it is equation 3. Let's say, okay, and this is equation 4. Great. So b plus c plus d, and this is all those things minus. We can actually, when you take away, then when you add them, you get 2c equals to minus 2, right? So if you add equation 3 with equation 4, what do you get? So minus b cancel, minus d cancel. So 2c equals to minus 2, and which gives you the value of c as minus 1. Is that clear to you? So we got c as minus 1 now. So let me write down here. C as minus 1. Good. So we know C also only things left are B and D for us, right? Okay, great. So C is minus 1. So once again, we can write down our function, which is f of x equals to A is 2, so 2x to the power of 4. B we don't know, so write bx cubed. C we know now, which is minus 1, so it is minus x squared. D we don't know, so dx. And E we know is minus 2. Correct. So we get this equation. Now, let us put the values of 2, right? So 2 is 6. Let's put f of 2 now. Which is 6, okay? So when you put 2 here, 2 to the power of 4 is 16 times 2 is 32. And plus 8b minus 2 square is 4. And plus 2d minus 2. So we get this equation. Clear, right? So as soon as you put 2 there, you get this equation. And now here, we can find what is 8b plus 2d, right? So 8b plus 2d equals to what? So 32 minus 2 means 30, and there is 6 there, correct? So you take away that. So 32 minus 2 is 30, and when you take away 6, you get 24, right? So minus 4 is also there, okay? So 32 take away 2 is 30, take away minus 4 is 26, and take away this gives you 20, correct? So what you get is minus 20 on the other side. So 8b plus 2d is minus 20. I can actually divide them all by 2, and then we get another equation dividing by 2 as 4b plus d equals to minus 10. Makes sense. So, so we have 4b plus d equals to minus 10. And earlier, since we know what c is, we can use one of our equations earlier, right? So from here, we'll use this equation, correct? So let me insert in between. So from here, we can say that b plus d is c, right? Which gives you b plus d equals to minus 1, correct? So we have b plus d equals to minus 1, correct? So we have 4b plus d equals to minus 10 and b plus d as minus 1, correct? Or let's take it on the fresh page, these two equations. You can, of course, see that if I kind of subtract one from the other, we do get the values of b and d, which we are going to do on the next page, correct? So the equations which we are working with are that, let me go back there once, remember that. So you can also write this equation as what? You can say uh, d is what, right? You could also say like d is equal to minus 1 minus b. Okay, so we'll use this equation. So we know d is minus 1 minus b, and we know 4b plus d is minus 10. So we'll substitute and get the answer. Okay, 4b plus d is minus 10. So we have 4b plus d equals to minus 10, and we know d is equal to uh, minus b minus 1, or you can write minus 1 minus b. So when I substitute that value here, so you get 4b minus 1 minus b equals to minus 10, right? So 3b equals to minus 10 plus 1, which is minus 9, or b equals to minus 9 by 3. So we get b equals to minus 9 by 3, correct? Simple. Now d is what? We can now get d. D is minus 1 minus b. So d is equal to minus 1. This is minus 3. Okay. Minus 1 minus of minus 3. So d is minus 1 plus 3, which is 2. So we know d is 2. And earlier we found what a is, right? So a we got it from finite difference as 2. We got the value of e from this value of 0 as minus 2, right? And c we found later as equal to what? C was minus 1. And here we found b is minus 3. And now d equals to 2. Correct. And therefore, we can now write down the function. So let's write down the function now. Quadratic function. A is 2. So 2x to the power of 4. B is minus 3. X cubed. C is minus 1. X squared. D is 2. So plus 2x. E is minus 2. Great. So that becomes the quadratic equation which we are looking for. That is how we can actually solve this particular problem. And you see how step by step we began with finite difference to confirm also that this is indeed a quadratic equation, right? Since we found the value of a, that was worthwhile an exercise. It actually saved the time. So instead of working with 5 equations simultaneously, you see how we effectively worked with only three equations. We found the value of a from finite difference. There's another technique which we'll be talking later of how to even reduce the working with equations further. Great. So from here, I hope you understand the best way of getting the polynomial equation, maybe degree 4, uh, from finite difference and thereby solving the equations. I hope it makes sense. Now, if you really want to get ready for some important tests or exams, an IBHL final is one of the best at school level. So if you are ready for that, you are actually ready for any at this level of high school. Feel free to write comments, share your views. In case you need the PDF of this particular file, you can actually send an email to globalmathinstitute@gmail.com. Also, feel free to write your problems since on this platform we do provide solutions to your questions very fast. Thank you and all the best.